Hi, in this example, we are going to do an ANOVA test with two sample independent mean populations. So in this case, because there's two samples that are independent, we do have a choice here. We could use ANOVA or we could use a two-sample t-test. And back in chapter 11, when we did a two-sample t-test, it was always with two samples, and ANOVA is with at least three or more independent means. So in this example, it's a really good example to show you that whether you use ANOVA or the two-sample t-test, that your results will be the same. ANOVA is that powerful, where essentially we could have started using it back in chapter 11. So this example is just solely to show the student that the two-sample t-test and ANOVA, that the outcome will rarely be any different. So let's go ahead and read the problem. The following data represents the independent measure study comparing two treatment conditions. Here is treatment 1 and here is treatment 2. And this is the level of the treatments. We're going to conduct an ANOVA test at a 0.05 level of significance, and we're going to round our answer to 3 decimal places. Now, in the real world, we would have to take our two columns of data and run a 95% confidence interval normal probability plot, a box plot, and making sure there are no outliers and that shows a normal pattern. So luckily for us at this point, we will assume all population ANOVA requirements are met, meaning in addition to those population requirements where samples are independent and samples, the samples come from an approximately normal population, the ANOVA requirements are additionally met where variances are the same, or at least the largest standard deviation of a sample is no more than 2 times the smallest standard deviation. I know lots of preliminary work that we don't have to do. So the first thing you'll want to do in order to get an F ratio or a p-value or a t-test statistic is go to your calculator and enter in these two columns of data into two lists. So go ahead and go to your calculator, hit stat, and go to edit. I've already entered in treatment 1 in column 1 or L1 and treatment 2 in column 2 or list 2 or L2. So if you haven't done that, go ahead and pause the video and go ahead and enter in those in your calculator. So the next thing we'll have to do is run an ANOVA test. So let's go ahead and go to stat and let's go to test and go all the way to the bottom, TCH, and it says ANOVA. So go ahead and hit enter and it takes you to the home screen and it's very simple, right? And so we have to go ahead and say, do ANOVA on these two lists. So list 1, comma, list 2, and then parenthesis, and hit enter. And notice it gives you all this information. If we hit the down arrow, we would see even more information. And recall that these factors and error is just remember the differences between samples and within samples, like between the samples and then within each sample. But we just really need the F to test statistic and the p-value. And we're going to round to 3 decimal places. So our F test statistic is pretty large. It is 10.768769, rounding correctly. And our p-value is 0.008. Great. Now what we're going to do is hit second quit. And now we're going to run the two sample independent tests, our chapter 11 stuff. So let's go to stat and test, and we'll do a two sample t-test, number 4. And we do have data. So we have list 1, list 2, and this will be a two-tail test, right? Because ANOVA, it says there is no difference between the means, or there is a difference. And then pooled stay no, and then let's go ahead and calculate. So our two sample t-test, notice our test statistic is 3.282, and our p-value rounded to 3 decimal places is 0.008. Notice the p-value from when we did ANOVA and the p-value from when we did the two sample t-test there were no differences. So they're exactly the same rounding to 3 decimals, right? So observing the p-values, was there a difference in the result of the hypothesis test? No, the p-values aren't that far off where it would change the outcome of the test. So the point is here is sometimes they're going to be exactly alike, and I bet you if I ran the ANOVA, we would see maybe the 4th or 5th decimal be different, right? Really far away. So the change is so small that it won't change the outcome. And so if we just submit, we'll see that all our parts are correct. I hope this helps.